Hello my dear students, once again welcome back to our online education platform for the integrated classes, the VAVA classes. So here we'll discuss indefinite integral. Now the introduction of indefinite integral. Students, you already know what is the integration. It is the reverse process of differentiation, and integration may be definite, it may be indefinite. Okay. So in differential calculus, we have learnt the method of finding the differential coefficient of a given function. That is, we know how to find derivative of a given function. Okay. So if you write d by dx of fx equal to g of x, it means that we can find gx when fx is given. And here this d by dx is just like a operator, it's just like a machine. Okay, so just like a function. So d by dx is a operator, and in this operator if you input fx, then the output will be gx. Okay, so d by dx is a operator. If you give input is fx, then the output is gx. Okay, if you put x, the output is 1. If you put x square, the output is 2x. If you put x cube, the corresponding output is 3x square. If your input is sin x, then the corresponding output is cos x. Okay. So here in this machine, if you give the input fx, you get the output gx. Okay, that is, we can find gx when fx is given. Now, can we find fx when gx is given? Okay, if fx is given, then you can find gx. Can we find fx when gx is given? That is, if you know d by dx of sin x is cos x. Okay, do you know derivative of which function is sec square x? That is, g of x is given. Can you evaluate f of x? Think about this. Okay, s, the answer is s. We can, if gx is given, we can evaluate fx. Then how if gx is given, then fx can be evaluated? Okay, by thinking this, mathematician evaluated another function, another operator, using which if gx is given, they can evaluate fx. That operator is named as antiderivative. That operator is called antiderivative. Okay. So antiderivative is the answer to this question, which is the inverse process of differentiation. That is, the function is given, then that function is derivative of which function can be evaluated by this process. That's why it is the reverse of derivative, it is the anti of derivative, it is the anti process of derivative, it is called as antiderivative. Okay. Now antiderivative is also called indefinite integral. It is called integral, and integral are divided into two parts. One is definite, other one is indefinite. So that's why antiderivative is called as indefinite integral. Okay. Antiderivative is also known as primitive. Sometimes it is called as primitive. Okay. So for this, let me consider myself d by dx of my body equal to cell. This is 100% sure. If I differentiate my body, what will I get? I will get only cell. Okay. If you differentiate, what is that called? If you differentiate t, you get a cup of tea. Okay. Yes. Or then if you integrate cell, then you get my body. But this is not 100% sure. Okay. If you differentiate my body, if in a machine, cutting machine, if I put my body, I will definitely get only some blood cells, some stones like that, some cells will be there. But by joining this cell, I will not 100% get my body. That is, you can say that if you throw a, suppose if you throw a cup, if you throw a cup, you get definitely some stones are there. But by joining the stone, you cannot exactly get that cup. Okay, that is my question. You may get my hand as that cell maybe of my hand, or you may even get my leg as that cell might be of my leg. Okay, or you may even get my organ as that cell of my organ. So we cannot predict that cell is of my hand or my leg or any organ. Okay, so that is, if you breaks up something, okay, then exactly you cannot add this. Breaking is easy. Derivative is like breaking. Derivative is like breaking. So you apply. If you apply derivative, suppose a thing is there, a pot is there. So you apply the derivative, it will break. It's break into some part like that. But by joining this, you cannot get exactly this figure. If you joining all this part, okay, it may be this part maybe goes to that part. So exactly you cannot get that figure. Okay, remember that exactly you cannot get that figure. How much work you put on this, but you cannot get the exact figure. This is called indefinite integration in the language of calculus. That is, if you break something, that is called derivative, and joining this thing to make that thing is called the reverse process of derivative, that is integration. This is all about things matter in calculus. Now there is a thing called constant of integration. Okay, suppose phi x and gx are two integral of f of x. Why constant of integration arise? That I am talking about here, because just like here, if you break something, you will get some. If you break a pot, you get some small stones. But joining this small stone, you definitely did not get the 100% that pot. That's why some constant of integration is arise in calculus. Okay, suppose phi x and gx are two integral of fx. That is, integration of fx dx may be phi x, or integration integration of fx dx equal to gx. That is, integration of fx equal to phi x and integration of fx equal to gx. Then differentiating both sides with respect to x. So fx equal to phi dash x and fx equal to g dash x. Okay, so g dash x minus phi dash x equal to fx minus fx equal to 0. So g of x minus phi of x derivative, whole derivative of gx minus phi of x equal to 0. That is, gx minus phi x equal to constant. So gx equal to phi x plus constant, where c is constant of integration. Okay, so here is gx equal to phi x plus c, where c is constant. Hence, if phi x is integral of fx, then phi x plus c is also integral of fx. Okay, thus integral of fx is not unique. Okay, integral of fx is not unique. Integration of fx is phi of x, and also phi of x plus c. And c may be any arbitrary constant. It may be phi x plus 1, it may be phi x plus 2, it may be phi x plus 3. So integration is not unique. But derivative is always unique, but integration is not unique. If you break a pot, you definitely get some amount of stone. That is unique. But joining this stone, if different people come, so okay, if 100 pots are there and 100 people come and they will break 100 pots, they will definitely get stone. Only we get stone. That is unique. Nothing will extra you get. But 100 people, when they join this pot to make the join this stone to make the pot, then I am 100% sure that none of them will get exact pot. Okay, So different parts will find here after joining, different parts will find. Okay, that's why breaking is differentiation, that is unique, but joining, combining, making the things once again is not easy. Integration, that's why integration is not easy, and integration is not unique. When you join, you will not get the exact thing. Okay, that's why integration is not easy and integration is not unique. It is not mentioned here integration not easy. Later you see integration is not easy because joining things is not easy, and integration when joining you not get the same thing. Okay, when you are making we are collecting the things, you will not get the same thing. That's why integration is not unique. Okay. So by virtue of this property, phi x is called the indefinite integral of f of x. That's why phi of x is called indefinite integral of f of x. Now we have some note. That it doesn't have any finite value, doesn't have any unique value. That's why it is called indefinite integral. Okay. Now we have some note on indefinite integral. There is no need to introduce an arbitrary constant after calculating each integral. By combining all arbitrary constants, we get a single arbitrary constant to the, that is denoted by capital letter C, which is added to the final answer. Suppose you are integrating 5 terms. So no need to write 5 constant, only you have to write only one constant, because all the constant will be added and will give a constant. That's why that arbitrary constant will be written only once with capital letter C in every indefinite integration. Okay. If the function capital f of x is an antiderivative of small f of x, then capital fx plus c is called the indefinite integral of the function f of x. Okay. If the function capital f of x is antiderivative of fx, then fx plus c is called the indefinite integral of the function small f of x. It is denoted by integration fx dx. Thus by definition, integration fx dx equal to capital fx plus c. If capital f dash x equal to f of x, integration fx dx equal to capital fx plus c. So capital f dash x equal to, if capital F dash x equal to small fx, then integration of this fx equal to integration of f dash x, that is fx plus c. Okay. So this symbol is elongated s, and this is the integrand. This is the symbol, this is the integrand, this is the constant of integration. Dx means the function is integrating with respect to x, just like d by dx, derivative with respect to x, but here integration symbol and dx means the function is integrating with respect to x. The process of finding the indefinite integral of a function is called integration. This process of finding the indefinite integral of a function is called integration. Okay. Now we have some note. For every function, indefinite integral will not exist. Okay. Just we have discussed a few seconds later that few seconds before that integration, indefinite integration is not easy to evaluate. So indefinite integration will not exist for every function. Okay. You can break everything, but we cannot combine everything. Okay. That's why integration is not exist for every function. Only if a function fx is continuous in an interval fv, okay, then that kind of function is integrable. Okay, then there exists an indefinite integral in that interval fb for the continuous function fx. This is symbol of integration operation. Integration is the inverse process of differentiation. It is the reverse process of differentiation. Any two integral of the same function differ by a constant. Okay. For if you get two integral of a function, then they should differ by a constant. D by dx of integration fx dx equal to fx, and integration of derivative of fx dx equal to fx plus c, because derivative of fx and integration will cancel, it will be fx, but a constant term will be added, because integration always give a constant fx plus c. But this time derivative and integration of fx also contain constant, but derivative constant is 0, that's why it's only fx. Okay. Now we'll discuss integral of some elementary function. Okay. Now standard integral, dy by dx of capital F of x equal to small f of x, that implies integration of fx dx equal to capital F of x plus constant, that is a arbitrary constant. So again d by dx of xn plus 1 by n plus 1 equal to xn. So integration xn dx equal to xn plus 1 by n plus 1 plus c. Derivative of xn plus 1 by n plus 1 is xn. You just find the derivative, d by dx of xn plus 1 by n plus 1. So here 1 by n plus 1 is constant, 1 by n plus 1 is constant. So d by dx of x to the power n plus 1, which equal to 1 by n plus 1, d by dx of xn, so n plus 1 x to the power n plus 1 minus 1. Okay. So n plus 1 cancel, x to the power n plus 1 minus 1 is x to the power n. Okay. So this derivative equal to x to the power n. So integration xn dx is x to the power n plus 1 by n plus 1 plus c. Okay. So integration of xn dx is x to the power n plus 1 by n plus 1 plus c. Actually integration of xn is xn plus 1 by x to the power n plus 1 by n plus 1. A constant is, arbitrary constant is added, because this is the constant of integration. Every time you have to add a constant, and here n should not be minus 1, n is restricted for minus 1 only. Okay. Now derivative of x equal to 1, you know, so integration of 1 dx is x plus c, constant is added, that is you can write here integration of dx is x plus c. Okay. This is important concept. Sometimes student forgot that what is integration of dx. No, nothing is given. No, integration it is then bhavanti na integration of dx hochi kana na x plus c. Okay, clear. D by dx of root x is 1 by 2 root x. You know already that formula. So integration of 1 by root x is 2 root x plus c. Okay. D by dx of mod x is mod x by x, x not equal to 0. So integration of mod x by x dx equal to mod x plus c. Okay. Derivative of e to the power x is e to the power x. So integration of e to the power x dx equal to e to the power x plus c. Derivative of a to the power x is a to the power x log a. So integration of a to the power x dx is a to the power x. You see here the derivative of ax is ax log a. So derivative of ax by log a, derivative of ax by log a, this is 1 by log a into derivative of a to the power x. Okay, this is equal to 1 by log a, derivative of a to the power x is a to the power x log a, so log a cancel, this is a to the power x plus c. Okay, so it is a to the power x plus c. So sorry, this is only a to the power x, not plus c, this is only a to the power x. So integration of a to the power x is a to the power x by log a plus c. Okay. Now derivative of log mod x is 1 by x, because integration of 1 by x, x not equal to 0, since x is not equal to 0, x may be positive or negative. If x is positive, it is mod x is 1. If x is negative, then also you see integration of 1 by x dx is log mod x. Okay. Derivative of log mod x is only 1 by x, so integration of 1 by x dx is log mod x plus c. Okay. Derivative of sin x is cos x, That implies integration of cos x dx equal to sin x plus c. Derivative of minus cos x is sin x. So integration of sin x dx equal to minus cos x plus c. Derivative of tan x equal to sec square x implies integration of sec square x dx equal to tan x plus c. Derivative of minus cot x is cosec square x. So that implies integration of cosec square dx is minus cot x plus c. Derivative of sec x is sec x tan x. So integration of sec x tan x equal to sec x plus c. Here in question number 7, you see, we know derivative of mod x is mod x by x. So derivative of log mod x, you see, you already know derivative. So derivative of log mod x, this is 1 by mod x, and by the chain rule, this is derivative of mod x. And derivative of mod x is mod x by x. So this is 1 by mod x into mod x by x when x is not equal to 0. So mod x cancel. This is 1 by x. Okay. So derivative of log mod x is 1 by x, whether x is positive or negative. That's why integration of 1 by x dx is log mod x. Log mod x plus c. C is the constant of integration. Okay. Now question number 13. Derivative of minus cosec x equal to cosec x into cot x. That's why integration of cosec x cot x is minus cosec x plus c. Minus, it's not cot x, minus cosec x plus c. Minus cosec x plus c. Okay. Derivative of sin inverse x is 1 by 1 minus x square root over, which is same as derivative of minus cos inverse x. So integration of 1 by 1 minus x square dx is sin inverse x plus c, and is also same as minus cos inverse x plus c. Or you can write integration of, or you can write the same as, now minus integration of 1 by 1 minus x square root over dx equal to minus cos inverse x plus c. 1 by 1 minus x square root over dx is sin inverse x plus c. This is equal to minus cos inverse x, or you can write minus 1 by 1 minus x square root over dx equal to only cos inverse x plus c. Okay. Derivative of tan inverse x is 1 by 1 plus x square. This is same as derivative of minus cot inverse x. So integration of 1 by 1 plus x square dx is tan inverse x plus c, or minus cot inverse x plus c. Or you can write integration of minus dx by 1 plus x square. Integration minus dx by 1 plus x square. This equal to cot inverse x plus c. Only integration dx by 1 plus x square is tan inverse x plus c. Integration minus dx by 1 plus x square is cot inverse x plus c. Okay. So these are the standard formula. Again, derivative of sec inverse x is 1 by mod x square minus 1 root over. Remember, this is mod x, 1 by mod x square minus 1 root over, which is derivative of minus cosec inverse x. So integration of dx by mod x square minus 1 root over equal to sec inverse x plus c, also equal to minus cosec inverse x plus c. Or you can write this as integration of dx by mod x square minus 1 root over is sec inverse x plus c. So integration minus dx by mod x square minus 1 root over, this equal to cosec inverse x plus c. So for positive this is sec inverse x, for negative it is cosec inverse x plus c. Okay. Derivative of sin hyperbolic x is cos hyperbolic x. So integration of cos hyperbolic x dx is sin hyperbolic x plus c. Derivative of cos hyperbolic x is sin hyperbolic x. So integration of sin hyperbolic x dx equal to cos hyperbolic x plus c. Derivative of tan hyperbolic x equal to sec hyperbolic square x. So integration sec hyperbolic square x dx is tan hyperbolic x plus c. Question number 20. Derivative of minus cot hyperbolic x is cosec hyperbolic square x. So integration of cosec hyperbolic square x dx is minus cot hyperbolic x plus c. Derivative of minus sec hyperbolic x is sec hyperbolic x into tan hyperbolic x. So integration of sec hyperbolic x tan hyperbolic x dx is minus sec hyperbolic x plus c. Derivative of minus cosec hyperbolic x is cosec hyperbolic x into cot hyperbolic x. So integration cosec hyperbolic x into cot hyperbolic x is minus cosec hyperbolic x plus c. Okay. So derivative of sin hyperbolic inverse x is 1 by 1 plus x square root over. So integration of 1 by 1 plus x square root over dx is sin hyperbolic inverse x plus c. It is also same as log x plus x square in x square plus 1 root over mod plus c. So derivative of cos hyperbolic inverse x is 1 by x square minus 1 root over. That implies integration of 1 by x square minus 1 root over dx is cos hyperbolic inverse x plus c. So also same as log x plus x square minus 1 root over mod plus c. If fx is an integral function and k is a real number, then integration of k fx dx is k time integration fx dx. If fx dx are two integral functions, then integration of f plus gx dx is integration fx dx plus integration gx dx. Okay, these two are rule of integration you can consider. Okay, just like derivative. Okay, so derivative of constant fx is constant time derivative of fx. Similarly, integration of constant fx equal to constant time integration of fx. Again, derivative of fx plus dx equal to derivative of fx plus derivative of gx. So integration of fx plus dx is integration of fx plus integration of gx. Okay. Now, if fx dx are two integrable functions, then integration of f minus gx dx equal to integration fx dx minus integration gx dx. If f1x, f2x, fnx are integrable functions, then integration f1, f2 up to fnx dx equal to integration f1x plus integration f2x plus integration fnx dx. So for subtraction, integration is worked like derivative. Again, for n number of integrable function, integration of f1, f2, fn is same as integration of f1 plus integration of f2 plus integration of fn. That is integration of sum equal to sum of integration. Integration of difference equal to difference of integration. Similarly, here also it is not restricted to two functions. You can write fx minus gx minus hx is same as integration of fx minus integration gx minus integration hx. Again, fx gx are two integral function and k and l are two real number, then integration kf minus lgx dx is k time integration fx dx minus l time integration gx dx. That is integration of kfx minus lgx dx equal to integration kfx dx minus integration lgx dx. So k time integration fx dx minus l time integration gx dx. So this is all about the basic introduction of indefinite integral. Okay, and these are the definition. These are the basic definition, and one these are the very basic standard formula, and one more formula will be added with it. If you see, let f1, f2, fn are continuous function in a interval, that is these are integrable. So you can write f1, f2, f3 up to fn are n integrable function, and k1, k2 up to kn are n constant, then integration k1 f1 plus k2 f2 plus kn fn of x dx equal to k1 f1 x plus k2 f2 x plus k3 f3 x up to kn fn x dx. This is integration. Okay, so this equal to integration k1 f1 x dx plus integration k2 f2 x dx plus integration kn fn x dx. Okay, so this, since k1 k2 kn are constant, so this is k1 integration f1 x dx plus k2 integration f2 x dx plus kn integration fn x dx. Okay, so this is the basic formula, basic definition. And if in case of plus you add minus, then also it work, so for both plus or minus, it the formula is work. Okay, again this can be expressed using summation. This term can be expressed using summation. Okay, now this can be expressed in using summation like this way. So in first you have got the formula k1 f1 k2 f2 kn fn is same as integration k1 integration f1 k2 integration f2 kn integration fn. Again integration summation I equal to 1 to n ki fi x dx. This is same as summation I equal to 1 to n ki integration fi x dx. These two things are same but expressed using summation. Okay, integration summation I equal to 1 to n ki fi, that is integration of k1 f1 k2 f2 f2 kn fn. This equal to k1 f1 k2 f2 kn fn, that is same as summation I equal to 1 to n ki fi k1 f1 k2 f2 kn fn. Clear? So this is another interesting formula of indefinite integral. So we have discussed what is indefinite integral, its basic definition and various formula. So remember this standard formula and some rules. So using this formula and rules, we will solve problem in the next PPT. So till then, have a nice day. Bye bye students. Thank you once again. Okay. So पढ़ी आस next class रे आमे सब problem and our more discussion करिबा indefinite integral. So thank you once again students.